this question, there's a parallelogram PQRS on the coordinate plane, and diagonals SQ and PR intersect at the point T. It says find the coordinates of point Q in terms of A, B, and C. So we're looking for this point. If we know that this is a parallelogram, we know that all opposite sides are congruent. So we know that this side is the same length as this side. So if this one shifts over, and we're moving left to right, so that's our X, okay? So if this one shifts over to B, well, we know that this part here is 2B. So right here, the X is 2A. Then we have to add 2B to that. So our X is 2A plus 2B. Then we're looking at our height, our y-axis, and if this is 2C, this also has to be 2C. It doesn't change left to right. It stays up and down, because if this is on that x-axis, this one has to be on that, whatever that y is. It doesn't change. So this is that answer. We have the same parallelogram, and it's saying that SQ, this one, and PR bisect each other. And it wants us to make sure that they do bisect each other. So we're going to find the midpoint of SQ and then find the midpoint of PR and make sure it is the same midpoint. So if we remember, our midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. That whole thing is out there. So we're just going to do this for SQ and PR. So let's start with SQ. We have our x1. This is our x1, y1, and this would be our x2, y2. It doesn't matter if you use S as your second point and Q as your first point. It doesn't matter which one. So we're going to do x1, which is 0, plus x2, which is 2a plus 2b over 2. And then y1, which is 0, plus y2, which is 2c over 2. And we can reduce all of these. We can divide 2 into every one of these. So if we did that, we'd end up with 0 divided by 2 is 0. So we don't have to write that. So 2 divided by 2 is 1a plus b. We don't have to write it over 1 because 2 goes into 2 one time. We don't have to do that. And then same thing. 0 divided by 2 is 0. And 2 divided by 2 is 1, and we don't have to write it over there. So that is the point T, or your midpoint of SQ, okay? And so let's try it with PR now. So x1, if I do this, once again, it doesn't matter which one's my second or first point. It would all work out the same way. So if we do x1 is 2b and x2 is 2a over 2. And then for my y1 is 2c plus y2 is 0. We're going to divide those by 2. So 2 divided by 2 is 1. And 2 divided by 2 again is 1. So we're going to do a. I'm sorry, it's not over 2 anymore because 2 goes into 2 one time. And then 2 divided by 2 is 1. We don't have to write the 0. Now, if they really did bisect each other, this would be the same midpoint for each one. Well, there's something different with these two. All I have to do, though, is switch those around. B plus A is the same thing as A plus B. All the signs are the same. So because the midpoint of these two is the same, yes, they bisect each other. If you remember when we were doing trig of right triangles, we said that the cosine of one angle is the same as the sine of the other, not including the right angle. So we can't talk about the right angle. So the sine of B equals the cosine of C. And the cosine of B equals the sine of C. So it works out that way. So we're going to do some little substitution here. So in the right triangle ABC, measurement of angle B is not congruent to the measurement of angle C. So that doesn't work out if these are the same measure. But they're not. So then it says let sine of B equal R and cosine of B equal S. What is sine of C minus the cosine of C? So sine of B, if we look right here, the sine of B is the same as the cosine of C. So that means if the sine of B is R, the cosine of C is R. And cosine of B equals the sine of C. So this would equal that. And so then it says, what is the sine of C, which is S, minus the cosine of C, which is R. I realize there's no drop-down menu for these, but this is easy. We can figure this out without having to have a multiple choice here. So they're asking us to dilate this, and they tell us a scale factor of 3, and then what is the relationship between these things. So if I dilated this, and so that means I'd have to bring this larger. Okay, and so this would be A prime here, C prime, and then I'd have B prime here, and it would go there. So there's my dilation. But if we remember, a dilation brings sides to they're going to be parallel. So AC is going to be parallel to A prime, C prime. AB is going to be parallel here. So that's going to help us in just a second. So it says side A prime, B prime will blank side AB. So that's going to be parallel. And remember, you may see the sign this for parallel. And then it says side AC will blank side AC. I'm sorry. A prime, C prime will blank side AC. It probably says in this drop down menu would be is or will be parallel to. So same thing. And then side BC will blank side BC. So if I'm looking, side BC will blank side, or side B, I'm sorry, B prime, C prime will blank side B side. This will be on the same line. And of course you would have options to look at, and that probably would have been common sense there. Once again, we're trying to find a side of a triangle. It doesn't tell us if these triangles are congruent or similar or whatever, but we can figure this out to see. Remember, if they're similar, we can set up proportions. So let's see. We know we have one angle that's 38 and one angle that's 38 here, but we're not giving the corresponding angles with the 68 and 74. So let's see if I add these two together, that would give me 106. And I know all the triangles all the angles in a triangle equal 180 degrees. So if I subtract that, I would get 74, and that would be 74 degrees, which means since this one and this one are 74, this would be 68. If I wanted to, I could have added the two angles in the larger triangle and found that angle F would have been 68. So these are similar triangles. So now we know we can set up a proportion. If I look at it, triangle ABC is congruent to, and we have to go with our angles. So if A is 68, it goes with F. And then B is 74, so that goes with E. And then C is 38, and that goes with D. So make sure that you put the correct angles together. So I need to set up a proportion here. I know I'm going to use side BC and DE because those are the ones that correspond to each other. So I can go ahead and set that up. I'm going to put the smaller one on top. And then I can use AC and DE together, or I can use AB and EF. It doesn't matter which one I use. But I don't have AC and I don't have DF. So let's make it easy on ourselves and use AB and EF. So AB, the smaller one, over EF. And then multiply these out, and you get 10 times 15 is 150. And then 6x. And then I'm going to divide by 6. And I get 25. So the value of x is 25. A dilation with a center at 0, 0, and a scale factor of k is applied to segment M. Let segment M prime N prime represent the image of Mn after the dilation. It says select each correct answer, which probably means there's more than one when it says that. So we need to talk about scale factor. It doesn't give us a number, so we don't know if it's bigger or smaller. So we're just going to remember, dilation doesn't always mean that it's larger than the pre-image. In fact, if k is bigger than 1, then it's enlargement, or it is bigger, okay? If k is smaller than 1, but it also has to be bigger than 0. It can't be less than 0. It can't have a negative number. Then this is a reduction. It means it's smaller. And then if k equals 1, then it's the same, okay? It's also called isometry, but it's the same size. So let's look at these. On the A option, if k is greater than 0, so if k is greater than 0, it says that the image is bigger than that. Well, that doesn't always mean that. It could be greater than 0, but still be a reduction. Here, it's definitely greater than 0, and it's an enlargement. But if it's in between 0 and 1, then it could be a reduction. So this isn't always true. It's only sometimes true. So we can't pick things that are sometimes true. Okay, if k is greater than 1, then the image is greater than the pre-image. That is true. Okay, if 0 is less than k, so this is saying if k is greater than 0, but less than 1, or and less than 1, then the image is less than the pre-image. And that's what this means right here. So that's true. If 0.5 is less than k is less than 1.5, then the image is less than the pre-image. So if k is less than 1.5 and greater than 0.5, then that means that it's bigger the second time? No, because that could still fall in some of it's bigger, some of it's smaller. Because 0.5 is smaller than 1, so that would mean it's a reduction, but 1.5 is larger than 1. So that would mean it's an enlargement. So can't really do anything with that one. If k equals 1, then the image equals the pre-image. Absolutely. And then if k is 0.5, then the image is 0.5 times, and it's going to be bigger, 0.5, it's going to be smaller, 0.5 times the pre-image. Absolutely.